The live stream began like any other historic moment in space exploration, with calm voices and polished graphics. A countdown clock hovering in the corner of the screen as millions of viewers around the world leaned forward in their chairs. The object designated 3I/Atlas had already rewritten astronomy textbooks simply by existing. Only the third confirmed interstellar visitor ever recorded. It was moving faster than anything gravitational models comfortably explained, and its trajectory through the inner solar system had shifted twice in ways scientists publicly attributed to outgassing jets. Tonight, NASA promised the closest live observation yet, as the object skimmed inside Mars' orbit, illuminated by the sun's fierce glare. The feed cut to a control room filled with muted tension. Analysts in headsets watched streams of spectral data while a lead astrophysicist explained that 3/Atlas exhibited complex rotational behavior and non-uniform albedo signatures. The words were technical, steady, reassuring. The object appeared on screen as a brilliant point of light against velvet darkness. Magnified through adaptive optics, it tumbled irregularly, its surface flashing in erratic bursts. At first, the irregularities seemed ordinary. Cosmic debris often spins chaotically. Ice sublimates unevenly, but about 20 minutes into the stream, a faint shimmer appeared beside the object, not bright enough to draw immediate attention, just a fleeting glint that seemed almost too sharp. It vanished as quickly as it came. Viewers in a live stream chat began to post timestamps. Someone replayed a clip and slowed it down. The shimmer returned frame by frame, revealing what looked less like a random reflection and more like a straight edge, catching sunlight. A clean, defined line. The on-screen astrophysicists continued speaking about volatile compounds detected in the coma, unaware or unwilling to acknowledge the growing storm in the chat. Social media platforms lit up with side-by-side comparisons, enhanced screenshots, overlays tracing geometric shapes. A second glint appeared, this time 90 seconds after the first, at nearly the exact same rotational phase. The pattern was too precise to ignore. In the control room feed, one of the technicians leaned closer to her monitor. The camera angle shifted slightly, as though someone off-screen had spoken. The lead commentator paused mid-sentence, music, eyes flicking toward another display. For half a second, the audio crackled. Then a telemetry overlay flickered on. It wasn't meant for public viewing. A vector arrow extended from music, the object representing its calculated velocity relative to the sun. Another arrow appeared moments later, faint but distinct, angled 2 degrees off the projected path. The second arrow blinked once and disappeared. The astrophysicist cleared his throat. We are currently experiencing minor visualization artifacts, he said. The cadence rehearsed. Please note that compression effect can create geometric illusions in high contrast imagery, but the chat had already captured it. Seconds later, the object emitted a pulse of light. It was not the diffuse flare of sublimating gas. It was not the irregular sparkle of rotating rock. It was a coherent flash, bright and uniform, expanding outward in a thin circular wave before fading into the surrounding glare. The control room fell silent. Microphones picked up the soft hum of equipment and nothing else. The pulse coincided with a sudden spike in solar interference across the feed. Static rippled through the audio. The image stuttered and then framed for barely 3 frames of video. Something resolved against the sun's halo. A silhouette partially occluded by glare, but unmistakably structured. Parallel edges. Symmetry, a curve that met a straight plane at a precise angle. Not chaotic, not natural. The chat exploded. Within seconds, hashtags began trending. Globally, clips were downloaded, mirrored, analyzed. Independent astronomers pointed backyard telescopes toward the coordinates, confirming unusual brightness fluctuations, inconsistent with a tumbling comet. Nucleus. The live stream continued for exactly 12 more seconds, during which the lead scientist stared at something off-screen with an expression that cameras rarely capture in professionals trained for composure. Then the feed cut to a static NASA logo and a message live. Stream temporarily paused due to technical difficulties. Silence followed. The internet did not remain silent. Frame-by-frame breakdowns flooded every platform. Amateur image. Analysts enhanced contrast, isolated edges, mapped rotational intervals. A pattern emerged in the flashes. A repeating interval not aligned with gravitational torque models. The object appeared to be adjusting its orientation, deliberately presenting flat surfaces to the sun in measured music sequences. 2 hours after the cut, NASA released a brief statement attributing the anomalies to sensor saturation and data compression artifacts exacerbated by solar proximity. They emphasized that 3I/Atlas remained a natural, interstellar body exhibiting non-gravitational acceleration likely caused by asymmetric outgassing, but independent observatories were not convinced. In Chile, an array detected a faint radio frequency spike synchronized with the exact moment of the pulse, captured on the live stream. In Australia, a deep space antenna recorded a narrow band anomaly embedded within solar noise, repeating every 11 minutes. The signal was weak, but it was patterned. Behind closed doors, emergency meetings convened. Military tracking assets quietly adjusted their orientation. A classified orbital platform redirected its sensors toward Music 3I/Atlas. Internal memos circulated, noting that the object's most recent trajectory update placed it marginally closer to Earth's orbital plane than previously calculated. The margin was small, but measurable. The following morning, NASA restored the live stream without fanfare. The object appeared unchanged at first glance, still brilliant against darkness. The commentators resumed their measured tone, discussing spectroscopic readings and dust composition. They did not mention the pulse. They did not mention the silhouette, but viewers were watching music more closely now. 10 minutes into the resumed feed, the object brightened again, though less dramatically than before. This time, no silhouette was visible. Instead, a faint, lattice-like pattern shimmered across its surface for a fraction of a second, too subtle to trigger an immediate cutoff. The feed continued. Meanwhile, power grid monitors around the world recorded a synchronized microsecond fluctuation in load distribution at the exact moment of the earlier pulse. It was tiny, nearly lost in noise, but present across multiple continents. Data. Scientists began comparing timestamps, the conclusion forming quietly among those with access to global network. Telemetry was unsettling. At the moment the object pulsed, Earth pulsed back. Billions of devices connected to the internet had surged with activity as viewers reacted to what they saw. That surge created a measurable electromagnetic footprint radiating into space, a planetary heartbeat. And 3I/Atlas had been oriented directly toward Earth at that exact second. The possibility that began to circulate in private discussions was no longer about propulsion or exotic ice chemistry. It was about observation, about calibration, about something using reflected sunlight, not as camouflage, but as a mirror. 3 days later, the object executed another minute trajectory shift, small, precise, aligning it once more with Earth's position. This time there was no live stream, Official statements grew more restrained. Words like artifact and natural explanation were repeated with increasing frequency. Yet data continued to leak. An internal slide deck surfaced briefly online before being removed, showing a three-dimensional reconstruction of the silhouette captured in those three frames. The model displayed bilateral symmetry and planar music surfaces meeting at exact angles. Engineers who saw it described it with one word: designed. As 3I/Atlas approached its closest solar pass, its acceleration increased beyond predicted values. Not explosively, not in a way that would threaten impact, but enough to demonstrate control. It slowed slightly as it crossed Earth's orbital plane, lingering longer than gravity alone would permit. Deep space probes detected another narrow-band emission. This time, the signal was clearer, embedded within. The carrier wave was a repeating mathematical sequence, simple at first, prime numbers ascending, then something more complex, a modulation that matched the spectral signature of Earth's atmospheric composition, as if mirroring it, as if acknowledging it. The world was not told. Instead, the public saw carefully edited images and heard cautious reassurances. The word artifact trended again. So it did another word: contact. Late one evening, without announcement, NASA quietly reactivated the live stream. No introduction, no countdown, just a live feed of 3I/Atlas suspended against the stars. It was no longer tumbling. It was stable, one broad surface angled toward Earth, reflecting sunlight in a steady, unwavering glow. The brightness did not fluctuate. It held for nearly a full minute. The object remained perfectly oriented. The feed did not cut. The commentators did not speak. Across the music planet, millions watched in silence. Then, slowly, almost gently, 3I/Atlas began to rotate away. Its light diminished incrementally as its angle shifted like a curtain closing. Its velocity vector adjusted once more, subtle but undeniable, redirecting it toward the outer solar system. Music, it was leaving, not slingshotting, chaotically, not expelled by solar radiation alone, but departing along a path that maximized gravitational efficiency, as if plotted with intention. The live stream continued until the object became a faint point, indistinguishable from distant stars. This time when the feed ended, there was no technical difficulty screen, only a quiet sign off thanking viewers for their interest in ongoing research. In the weeks that followed, debates raged. Papers were drafted and retracted. Whispers circulated about the data exchange detected during the first pulse, about the planetary electromagnetic surge, about the mirrored atmospheric signature encoded in the second emission. Officially, 3I/Atlas would be remembered as a rare interstellar comet exhibiting unusual but natural behavior. Unofficially, among those who had watched those 3 frames before the cut, it would be remembered as something else. Not a visitor seeking to land, not an invader seeking to conquer, but an observer that had paused at the edge of a young civilization, turned its face toward the noise of billions of minds, lighting up at once, measured it, mirrored it, and then chosen to move on. Long after it vanished from telescopes, astronomers continued scanning the darkness for similar signatures. They recalibrated instruments to detect not just light but pattern, not just motion but intention. And somewhere beyond the reach of our strongest signals, beyond the faint echo of our planetary heartbeat, 3I/Atlas carried with it a snapshot of Earth at the precise moment humanity realized it was no longer alone in being watched. The live stream had been cut, but the exchange had already happened. In the months that followed, the official narrative settled like dust over a crime. See, no one was allowed to enter. Panels were convened, datasets were partitioned, and public reports were distilled into language so sterile it seemed almost artificial. The phrase, non-gravitational acceleration, appeared again and again, stretched thin across explanations that no longer satisfied even the most cautious observers. Yet, among researchers who had archived the raw feed before it disappeared, there was an unspoken understanding that the most important moment had not been the silhouette itself, but the timing. The first pulse had not occurred randomly. It had happened at the exact peak of global viewership. Data analysts later reconstructed internet traffic patterns and discovered that the spike in bandwidth coincided down to the millisecond with the flash from 3I/Atlas. Billions of devices had surged, with notifications, comments, shares, and downloads. In that instant, the planet's electromagnetic profile had shifted measurably. Satellites, monitoring ionospheric conditions, recorded a faint ripple not unlike the subtle tremor of a heartbeat. The object had been facing Earth at that precise moment. Privately, a small working group began modeling scenarios. They stripped away assumptions about propulsion and asked a different question. What if the object's purpose was not travel but sampling? Its path through the solar system had been remarkably efficient, dipping just close enough to the sun to power sensors or systems through intense music solar flux, then aligning with Earth during peak technological activity. It had lingered in our orbital plane longer than physics alone required. It had pulsed once, received a response in the form of planetary scale electromagnetic noise, and then pulsed again with a pattern signal that mirrored Earth's atmospheric signature. It had behaved less like a comet and more like an instrument. Astronomers who had spent careers studying chaotic bodies found themselves confronting the discomfort of symmetry. The reconstructed silhouette from those three frames enhanced music through super-resolution algorithms revealed planar segments arranged in a radial configuration. The edges were too clean. The angles were too consistent. Even skeptics who resisted sensationalism admitted that natural fracturing rarely produced such regularity at that scale. Meanwhile, deep space listening arrays continued to monitor the trajectory of 3I/Atlas as it retreated beyond Mars. The narrow band emissions did not repeat with the same strength, but faint traces persisted, embedded in solar wind noise. Some researchers proposed that the initial strong signal had been directed specifically at Earth, and that subsequent emissions were broader, perhaps aimed elsewhere. The possibility that chilled many was simple. Earth had not been the only recipient. As weeks passed, a pattern emerged in archival solar observation data from years prior. Analysts revisiting old recordings found subtle anomalies in background radiation that had once been dismissed as equipment drift when mapped against historical peaks in global communication activity, major broadcasts, world events, mass digital surges. There were faint correlations, nothing definitive, nothing that would survive peer review, without controversy, but enough to raise a question no one wanted to phrase aloud. Had something been listening longer than anyone realized? Public attention gradually drifted to other headlines. The world has a way of absorbing the extraordinary and filing it away under unresolved mysteries. But within certain corridors, laboratories, without windows, conference rooms, shielded from signals, the conversation evolved from disbelief to preparation. If 3I/Atlas had been a probe, it had not demonstrated hostility. It had not altered course toward impact. It had not interfered with satellites or transmitted overt instructions. It had observed, measured, mirrored, and departed. That restraint suggested protocol. The next logical step was not panic but anticipation. Instrumentation budgets were quietly increased. Algorithms designed to detect exoplanets were modified to flag geometric light curves. Telescope networks were synchronized to reduce blind spots near the sun's glare, where another object could approach undetected until it was already within the inner system. The narrative presented to the public framed these upgrades as routine advancements in planetary defense and interstellar research. Behind the scenes, they were contingency planning. Years earlier, humanity had debated what message to send into the cosmos. Radio transmissions had carried greetings, mathematical constants, even music. Golden records had been affixed to probes drifting beyond the heliosphere. Those gestures were hopeful, almost romantic, but 3I/Atlas had inverted the premise. It had not asked for our message. It had taken a measurement instead, and perhaps that had been enough. One quiet night, nearly 8 months after the Livestream cut, a small observatory in the southern hemisphere detected a faint object emerging from the same vector 3I/Atlas had used upon entry. It was dimmer, slower, and music at first appeared indistinguishable from background debris, but its light curve was stable. Too stable. It did not tumble. It did not flare irregularly. It maintained a constant reflectivity that suggested orientation control. The discovery was not announced immediately. Cross-verification consumed days. Larger telescopes were trained on the coordinates. Spectral analysis revealed no typical cometary emissions, no volatile outgassing, no dust tail. The object's velocity was lower than 3I/Atlas had been, but still above escape speed relative to the sun. It was inbound. When the news finally reached the public, it was framed cautiously as a music potential interstellar object. Pending confirmation, no mention was made of symmetry. No reference was made to the previous pulse. The live music stream infrastructure, however, was activated within hours. This time the cameras rolled before peak viewership. The new object appeared as a faint, steady point. Commentators were careful, measured, almost rehearsed in their restraint. They emphasized the rarity of interstellar visitors, the excitement of discovery, the importance of data collection. Social media buzzed, but without the explosive fervor of the first event. The memory of the cutoff lingered, tempering reactions. As the object brightened with proximity, its light curve remained constant. Then at a moment when global traffic metrics indicated a modest but growing audience, the brightness increased by exactly 3%. It held for 10 seconds, then returned to baseline. No pulse, no dramatic flash, just a controlled modulation. Network monitors recorded a corresponding fluctuation in planetary electromagnetic noise, smaller than before but measurable. The object's orientation shifted slightly, angling toward Earth. It was difficult to avoid the implication. The world watched more intently now, not in shock but in recognition. Analysts compared the modulation pattern to archive data from 3I/Atlas. The intervals were different, but the structure of the change, precise, intentional, felt familiar. There was no feed cutoff this time, whether by decision or inevitability. The cameras remained live. The commentators did not speak during the brightness modulation. They allowed the silence to stretch, heavy and electric. Across continents, people experienced a shared awareness that transcended language. Not fear, not yet. Something closer to realization. The sky was no longer passive. It was responsive. The new object continued its steady approach, never accelerating beyond what gravity permitted, never deviating dramatically from a predictable arc. It seemed almost patient, as though music adjusting to the rhythm of human attention rather than demanding it. In secure facilities, simulations ran continuously. Music If these objects were probes, they were operating within strict parameters. Observe, measure, avoid interference. Their restraint implied boundaries. Perhaps ethical ones, perhaps strategic ones. The most unsettling hypothesis was also the simplest. Humanity had just entered a catalog, not conquered, not contacted in the cinematic sense, logged, assessed, added to a dataset of emerging technological civilizations whose electromagnetic signatures had reached detectable thresholds. The idea reframed everything. The pulse from 3I/Atlas had not been a greeting. It had been a calibration ping. The mirrored atmospheric sequence had not been a message. It had been confirmation of receipt. As the second object reached its perihelion, it performed no dramatic display. It maintained its steady luminosity, executed a gentle gravitational slingshot around the sun, and angled outward on a trajectory that would carry it beyond the heliosphere within decades. Before it receded beyond effective observation, it executed one final modulation, 5% brighter, 15 seconds, then darkness. The timestamp aligned with the highest synchronized music global live stream audience ever recorded. No one cut the feed. This time, the world saw it together without interruption. The silence that followed was not chaotic, but contemplative. The realization settled not as panic, but as perspective. Somewhere beyond the outer planets, two objects now traveled in widening arcs, carrying data no human would ever read. Within that data, perhaps was a record of a species capable of reacting collectively to the unknown, a measure of curiosity, a measure of restraint. Long after the second object faded into the black, telescopes remained fixed on the stars. The upgrades, music continued. The algorithms refined themselves, searching not only for rocks and ice, but for intention disguised as light. The live stream that had once been cut became a reference point in history, a reminder that sometimes the most important moments are the ones nearly hidden. But nothing had truly been hidden. The flash had been seen. The pattern had been recorded. The response had been measured. And somewhere in the vast dark, between stars, a quiet network of instruments might already be adjusting course, having determined that Earth was no longer just a source of random noise in the cosmic background, but a signal worth revisiting. The next time something approaches from interstellar space, humanity will be watching differently, and perhaps so will they. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.